Hello and welcome back to the Cracking Fang YouTube channel. Today we are doing another mock product architecture interview. Like the previous video, this is meant to be for information purposes only, and these are just some of the considerations that come to my mind when designing a system like this. This is meant to stimulate you to understand what sorts of things you need to discuss in these types of interviews. This is by no means a guide on what to say. As a matter of fact, if you simply regurgitate the exact points I make here, I'm 100% certain that you will not pass because it will not come off as genuine. So please do not take this as the only solution or the best solution to this problem. Use it for inspiration and then come up with your own solution. For this design, the goal is to present it at about the E5 level in terms of depth. Okay, let's get into it. Okay, so as you saw from the introduction, there was an icon of Instagram, and that should give you the hint that today we're actually going to be designing Instagram. Now, I don't think it's very useful for me to just blab for 40 minutes and just give a potential solution here. I think what would be more useful here is if I go through the design, I go through the kind of approach that I would take in a real interview, except I'm actually going to break the fourth wall and take breaks and pauses to explain things or indicate where you might want to deep dive more or where you might want to research more or some things you might want to talk about, as opposed to just going through a solution, because that's not really a realistic approach to these kind of problems, in the sense that on the day, it's a conversation with your interviewer. They're going to be more interested in certain parts of the problem. They're going to ask you to deep dive in certain areas. They're going to probe your knowledge on things that they want to ask you about. So it's not really useful for me to just blab, because that's not how it's going to go in a real interview. There's going to be pauses, breaks. They're going to ask you questions. You're going to have to answer back to them. So just, a 40-minute monologue is not really indicative of reality. That being said, let's go into the first part. So obviously we know that we're going to be designing Instagram. So what features do we want? Obviously Instagram is a massive app that's been developed over many years. So we're obviously not going to build the whole thing. The most basic thing that we want is to be able to post photos and videos. And we're also going to want to be able to see a news feed of followers content, right? Pretty simple. Post some videos and photos and then see that in some sort of news feed. Now, in terms of scale, obviously this is where the interviewer is going to tell you. You're going to ask them questions like, how many users do we have? How many photos a day are they uploading? What's the average size of the photo? Again, we don't have an interviewer here, so I'm just going to tell you it off the bat. So let's just assume that we have 500 million users. Let's just say 50 million of them are daily active users. We're going to have 2 million photos uploaded per day. We're going to have 500K videos uploaded per day. Average size, so for a photo, let's just say it's 200 kilobytes. And then for a video, we're just going to say it's 2 megabytes. Now, I'm not going to do the calculations here. Obviously, this is an important part of any interview, but it's really not useful for you, for me to do the math here. I mean, you can figure out how many requests per second are coming in. You can figure out the ingress and the egress based on the size of the kind of average video and how many are coming in per day and the average photo. So we're not going to do that part. We're just going to move to the next step, which is actually to kind of define what high-level data models we might want here. So obviously we have users, so we're going to need a user model, pretty straightforward. Each user is going to have an ID, probably a creation date, and then, some other metadata, right? We don't really need to go too much into the users. We just need to store some information about them. One area that you actually could deep dive here, and I'm not going to mention it because it doesn't really play too much into the entire design, but it's actually, how do you protect user data? How do you make sure it's actually deleted properly when the user deletes their account or requests their account to be removed? Things like EU's GDPR rules. How are you going to make sure that you're not storing more data than you want to? Again, this is a very complex topic, and perhaps there are some people who will be experts in this and they can kind of deep dive into what metadata do we actually need to store for the users and each of their information, their posts, any of the media they create. But for the purpose of this, I'm just going to mention it, that you can make a note that, maybe we don't want to store too much, or there's certain restrictions we might need to have, or we need a separate service to actually handle this. But at a high level, let's just say that we're storing some metadata that's legally allowed for us to store. We don't want to go down the rabbit hole of privacy and all of these things and data protection laws. That's a little bit outside of the scope of this, but if that's your area of expertise and you want to focus in on that and how that kind of ties into the user experience and the whole system as a whole, then feel free to do that. But again, I don't want to get off track. So we have the users. What else do we need? So obviously they're going to be able to make posts, which are going to show up on these newsfeed. So each post is going to have an ID. It's going to have a creator ID, which is going to be the user that we just, whoops, how do I do this? There we go. So this is the user. So they have the creator ID, so whoever created the post. What do we have? I don't know, whatever the caption might be on the post, how many likes there are. And, notice that as part of our kind of initial requirements, we actually didn't specify that we need to be able to leave comments on these posts. This is something you can follow up with your interviewer, but for the purpose of this very basic example, we're just going to assume that we don't do comments. But if you did do comments, then you would have the comments on the post, and then you need a separate comments model to actually store the comment metadata. But for this one, we're just going to assume that you just post things and you can only like it. You can't do comments. Okay, so that is a post. And then what is it going to be? So you also are going to have, I guess, the media ID, which is going to store the information about the media for that post, which means that we also need a media model. This is going to have ID, maybe the date it was created, and then the blob URL. So obviously, you can't store photos and videos in MySQL or Postgres. You're going to have to put this in some sort of blob storage. And typically, you're going to get a URL where that information actually lives. So those are kind of the high-level models we want. We have the user model, we have the post model, and we have the media model. And there's actually one more kind of model or table that we need. And this is actually going to be the following structure, right? So user follow. So this is really just going to be like user A, and then user B. So user A follows user B. And this is how we're going to determine who follows who, and then how we can actually determine the news feed, because you only want to see your followers' content. We can talk about later suggested content and stuff like this, but let's just assume that we need a table to store who follows who. And this relationship is not bidirectional. Unlike Facebook, when you actually friend someone on Instagram or when you follow them, they may not actually follow you back. So we cannot assume that this is bidirectional here. So anyway, that's really the main models that we need. Now what I want to do is, I guess we can talk about the high level kind of design here for our system and some of the components that might be necessary. So let us see. So obviously on one side, let's just say we're going to have clients here, and I am very specifically using two different kind of shapes here, and this is going to signify that most likely we're going to have clients who are going to come from the web, and we're going to have clients that come from mobile. And we're actually going to need to cater our design and kind of the considerations that we make on the app to account for the fact that we have different clients, and these clients have different requirements, and let's kind of take that into account. So we do want to make sure that we are aware that people will be accessing our app through different mediums and kind of the implications of this, but let's kind of get into that in a second. So obviously, with 500 million users and 500 million daily active users, we're going to get quite a lot of traffic on our system. So to kind of prevent everything from getting bogged down, let's just say that we're going to have some sort of like basic load balancer here. And again, these interviews aren't too much about scalability of a system. This is just kind of, let's just say that we need this. We don't have to elaborate how we're going to do the load balancing, how it's going to allocate requests. We just, at a high level, need to know that, we're getting a lot of traffic. Let's make sure that we don't overwhelm our systems. And, the main reason that we do this is because we want each user to have a good user experience. And again, we're going to be tying this back to kind of the user, the product, and how they're going to be interacting with this. If you send your request when you open the app, and then you have to wait a long time to get a response because the servers are overloaded, then you're not going to have a good user experience. So we have this load balancer to basically spread out our requests evenly and do our best to make sure that the machines receiving the request actually have, the capacity to handle it in some sort of reasonable amount of time. So that's really all I want to talk about the load balancer. I know there's a lot more technical stuff you can get into, and L4 load balancer, L7. This is a product architecture interview. You don't have to talk about these things, just the general high-level overview of why you might want a load balancer. Anyway, so now that we have the load balancer, obviously this is going to allocate requests to kind of like our tier of web servers here, and I'll kind of just duplicate these to imply that we're going to need multiple web servers on account that, obviously with this scale, you can't have just one server handling all these requests. You're going to need a fleet of them to spread out the load. Now, it's important to mention that we know that we're going to be uploading photos and videos, and we're going to be kind of reading the newsfeed and kind of giving that back to users, which means that we can actually delineate here two separate use cases, and we can kind of split our web server tier in two parts, right? One part is going to be the read part, and one part is going to be the write part. Because maybe fetching your newsfeed is a quick operation, but writing, maybe if you upload 4K video and you upload 10 4K videos for a post, then that's going to take quite a while. So maybe we want to separate it and have machines which are dedicated just for reading data and machines which are dedicated just for writing data. And the purpose of this is that the machines that are specialized for writing data, that's all they do, and we don't have to mix them, such that if you're trying to read but then the machine's clogged up because it's trying to process writes, that's going to be a bad experience for the user because they could have a high latency. So if we can actually split these two and have machines which just handle reading data and just handle writing data, we can give the user a better experience by having, all of their network requests actually process faster when they're trying to access data from the application. So, and again, you can go a lot more into detail here, how you want to do this, but again, I don't want to go too much into the rabbit hole. We only have 40 minutes and there's actually quite a lot I want to cover. But this is one of the areas where you can really deep dive. If you have the specific knowledge, you can do that. Okay, so what else do we need? So obviously, from kind of the web tier, what are some other components we need? Obviously, as we mentioned before, we need to store photos and videos in storage. And you don't just store photos and videos in MySQL, you store them in some sort of blob storage. So we're going to have blob storage. And, there's multiple kind of blob storage providers out there. You can use AWS S3, you can use GCP. I don't know what Microsoft Azure's solution is. You can have your own data center. Largely, it's all the same. I mean, each one has its pros and cons. It's not really going to affect the user too much. You're probably just going to go with the most cost-effective one, or whatever infrastructure is already available to you in the company. But for the most part, let's just say we have some blob storage. Now, we're also going to need a metadata DB. So obviously we defined all of our models here. We need to store them somewhere. We're not going to store them in the blob storage. So this is going to be our metadata DB. And this is where we're going to kind of store all of those models. Okay, so now we have our web server tier. And let's kind of think about what happens here, right? So people can read from our application, which means that they need to get their news feed. So let's just say that there is some service, news feed generation service. So we're going to have some other team or some owner of this service, which actually generates the news feed for us. Why is that gone blurry? And kind of let's think about this. So obviously this is the system which generates the news feed. So when the user wants to fetch from the read side, they're going to hit this service here. And I'm actually going to stop drawing the box the whole way on account that in order to actually give the user a good experience, we don't want to just call the newsfeed generation service each time. We're probably going to cache it. For most users, if we think about this at a high level, people are, on average, they're not going to have that many friends. Maybe they have 200, 300 friends, but, how often are these people going to post? Probably not frequent enough that, you know, we can actually cache their newsfeed and it should be fine. And then the newsfeed generation service can actually update this cache for us when something happens. So we can have, you know, reading from the cache if we need to kind of speed things up. So this will be kind of the cache for the service. And obviously the reason we have this is so you don't have to compute the newsfeed from the database every single time. You can cache it when something new happens. So someone's friend posts something, the newsfeed generation service will actually update the cache. And that way the cache will stay fresh and we can actually just read from the cache instead of having to compute everything cold, because that's going to take a long time, especially if our database is not set up correctly to actually process these things in an efficient manner. Again, how we set up the database, sharding, and the IDs to do that, that's more of a actual system design question. For the product design, we're not really interested in that. We're just more focused on kind of the user experience. So obviously we have kind of, let's just mark this. So update cache with new posts, fallback to DB if not in cache. So that's kind of the logic here. All right, so the web server tier, you know, obviously we have two events here, and either reading or writing. And the next thing that we probably want in our system is going to be some sort of async tier, which is going to process things. Now let's kind of draw this out before we go into it. And this is going to be, you know, a queue. So whenever something happens in the web server, most likely we're going to queue it for further processing. Certain events don't need to happen right away. If you upload, you know, some video or photo, you know, we can kind of push it to some workers to handle it for us in a second, or processing likes and follows, things like that. We don't have to do it instantly. And there's actually tricks that we can do on the UI to make it look like we've done it instantly. And we'll talk about those in a second, but kind of let's just assume that we have some sort of like, you know, queue here for processing all these operations. So we have an async queue. And this asynchronous queue is going to feed, you know, these events, and we'll kind of discuss what they might be. So this is going to be the async tier. And this is, you know, because we don't necessarily need to process everything at once, we can kind of punt it off and do it later. So if I can just get this perfectionism. Okay, so what might we want to do in the async tier? Well, we can do things like process likes. We can, you know, process follows. We can, you know, compress images. And we'll kind of talk about this in a second, because this is actually kind of a bit of a deep dive section. So let's just talk about that. And okay, so I think at this point, we kind of have the high level design here where, okay, the clients are making requests to our server. They're going to go through a load balancer to make sure that they go to an appropriate machine, which can handle the request. The web server tier is going to handle this request. It's going to be split between reading and writing to make sure that, you know, reads, which are generally less expensive operations, can happen quickly. Writes, which are more expensive operations, can be handled separately, and we don't have to kind of slow down the reads because we're waiting on writes. We're going to have async queue, which is going to take, you know, jobs from the async tier, things like processing likes, processing follows, compressing images, and it's going to get passed to the async tier. And the async tier, you know, for example, if it needs to, you know, store stuff in the database, for example, for a like, if it needs to put stuff in the blob storage, you know, if someone posts something new, then we want to tell the newsfeed generation service, and then the newsfeed generation service can update its cache, which we'll use for reading. So, you know, this is how all of the things click together. And there's actually one important element here that I forgot, and this is good for our users, is going to be a CDN. So obviously we are, you know, fetching static images and videos, and we don't want to be going to the blob storage every single time. We probably want a cache, which is going to be geolocated close to the user. And the reason for this is because we can serve this content much quicker and give the users a faster loading experience so that our app is quick, snappy, and doesn't lag, it doesn't jitter. You don't have to see those like constant flickering loading screens at all times. You can get the content that you want quickly, and this will be a better experience for the user. Now, let's kind of do a little bit of a deep dive while we're here when we have kind of the blob storage and the CDN in front of us. So one thing that we probably want to do is we don't want to store, don't store full resolution, videos and photos. The reason for this is, one, if you're uploading very high resolution content, this is very expensive to store. It's also very expensive to fetch. If you're uploading, a 5-minute long video and it's in, let's just say 8K for some reason, it's going to be huge. If you're going to try to fetch this and display it on the client, that's going to be a problem. So typically what we want to do is actually scale down the videos and photos. And we also need to store different sizes. Now, let's think about why we might want to do this in the context of giving the users a good experience. Now, if you're on mobile and you're on data, do you want to be fetching potentially when your phone or your friend uploads a 4K video that's like 3 minutes long and it's actually, 400 megabytes, and maybe you only have, 2 gigs of data? Are you going to eat up that much data to load this thing? Probably not. You don't want to see the full thing. Plus, I don't know what the best phone is these days, but even on an iPhone, it's not 8K resolution. You don't need the full video. You can actually downscale it to whatever kind of the best phone is. And we can kind of think about this as, can we classify user devices into buckets. I cannot type. Such that we can fetch the appropriate size for the user's device so we don't actually waste network packets. For example, it's easy to assume, okay, maybe you're living in the United States or in some highly developed country, you have 5G everywhere, the internet's really fast, and you have unlimited data. Who cares how much data is coming over the network? But let's say you live in a third world country, probably you have very limited data, or maybe you don't even have 4G, you're still on 3G. You're not going to be able to fetch these videos. So most likely you're going to want some sort of very scaled back version of the original content, such that you can still enjoy the content, but you don't have to kill your network and you don't have to kill the amount of data you have available to you in the case that you don't have much. So we actually don't want to be storing the full resolution videos because, again, we don't need it. Plus, for mobile clients especially, this presents a bit of a problem here because we can't just fetch and display all these like massive videos and photos. Typically, we just want some kind of downscaled version. So just going to grab a sip of my water here. Okay. So that's the general kind of high level of the system. Now, another part we're going to need to do is actually define some of the APIs we might need here. So let's do that now, and then we'll kind of talk about some of the deep dives of this problem. So what is one of the APIs? So obviously we need a post photo API, and this is going to take the user ID that's uploading the photo, or I guess like we can make this generic. We can, oops, what happened here? We can, why don't we just say make post, and this is going to be the user ID, the I guess media metadata, and this will be kind of, I guess, like a vector of media, where media can be a photo or a video, the caption for that, and then maybe some other kind of metadata. Okay, and this is going to probably return a response. Did it complete successfully? Did it not complete successfully? Actually, let's not worry about the responses for now. Let's just talk about kind of each of the APIs, and then we can go into more detail as we go on. So We can probably like a post. So we have the user ID and the post ID. And I guess this will just, oh yeah, we're not going to do return times at the moment. Forgot. So you can like a post. What else can you do? I guess you could delete a post. So you have the user ID and the post ID. That could be an API we might need. What else we might need? So follow user. So you'll do your user ID and then the followee or to follow ID, I guess. So this is the person that you're following. What else? So obviously we need the fetch feed. Now, fetch feed is interesting, and I think there's some things we can do here. So obviously you're going to need the user ID, and let's think about this. Do we want to fetch the feed every single time from the beginning of time? Probably not. We probably want to just fetch from the last time that we fetched, because there's no reason to refetch things that we already have. And this actually plays into kind of one of the deep dives we can do. And let's just say from the start time, and then, I don't know, potentially device class if we're on mobile, as we said. So kind of let's do a bit of a deep dive here. So we remember that when we are fetching, we're going to get something back from our newsfeed generation service, and this is going to get returned to us. Now, if we're thinking about this, to give the user the best experience, we probably want to store the feed that we fetched locally on their device. And the reason that we want to do this is because for most people, their feed isn't really going to change that much, because people, aren't really that active. If you think about Instagram, yes, some people post a lot, and maybe you have you're following some celebrities that post a lot, but for the most part, the feed doesn't really change too much in a short period of time. So you can actually just store this on the device, and the next time you ask for the feed by, for example, scrolling down or refreshing the page, if nothing's actually changed, then we don't need to refetch everything. We can, if anything, fetch the difference in the feed here. So, we can store, we can cache feed on the client side and only fetch the new posts since the last time we fetched. So that way we don't actually have to overfetch data. We can actually just fetch what we need, and it should be a better user experience. Because when they open the app, if we think about it, if things are already cached on their device, then we can just render the feed that we already have right away. And we don't have to, show loading, flickering things and, oh, this is loading, this next post is loading. It looks like the app is ready to go. And then we can just fetch what we need from the last time they actually refresh their feed, and it should be much less. It should be a smaller request, and we actually will save time there. So that's one way we can actually improve the user experience, is by caching this information. Now, remember when we talked about kind of not storing the full size of videos? Well, if we're on mobile, then we have the concept of a device class, because the latest iPhone, what are we on, the 15 Pro Max now, compared to some Android from 10 years ago. Those are two very different devices with different capabilities, and obviously the resolution is going to be different on the iPhone. If you try to render a photo that you might have shown to someone with a 15-year-old device, okay, maybe no one has a 15-year-old device, but I don't know, 7-year-old device where the resolution is much worse, then it's going to look terrible on the iPhone. So you want to get the highest resolution possible that you're storing to show it to that high-end iPhone user, so they get nice videos. Because even if you have the app working as it should, if all the content is pixelated or scaly and it just looks terrible, you're not going to want to use the app. So we want to fetch the best kind of image that we can for the given user's device class. And most of the times, this is like a consideration that you make on mobile, because there is a huge fluctuation in devices. Believe it or not, people do use old devices. I know in the US, people get the new iPhone like basically every single year, and they're like, oh my God, you still have an iPhone 10? Like, what is this, the Stone Age? But no, actually, there's people with even older devices, and this is something that you need to think about. So again, that's the reason why, one, we don't store the full resolution videos, and then we scale it so we can actually serve based on the device class. And this makes sense, right? If you have an old Android phone and you're trying to request some very high scale image or video, and maybe your network's really bad, because most likely if you have an old Android phone, maybe you just refuse to upgrade, or maybe you're in a third world country and you just can't afford the newest iPhone and you're using an older device, and maybe you don't have access to super fast internet and lots of available data like you might have in the United States. So people like this, you don't want to be serving them the highest quality content, because it's going to eat up their data, and maybe they have a very limited amount. So these are the things that you want to talk about. You could really go into depth here. This is just kind of high level overview of this topic. If you really wanted to dive deep here, you could. Okay. So those are kind of some of the high-level APIs that we have. Now, I don't want to get too much into this, but what are kind of some other considerations that we want to make here? When actually fetching data from the server, there's a bit of a delineation we need to make, and that is, do we want to operate on a push model or a pull model? So, the basic difference is when something happens. For example, when one of your friends posts a new photo, are we going to push that to your device and you have it immediately, or are we going to wait for you to actually request the information from the server? So for example, if you're using Instagram on your phone, where you actually scroll to the top and kind of pull down, and then it will fetch new content. Which one do we want to do, and kind of which kind of technologies would we need here? So obviously, typically, this is, you're going to have, if you want a push model where you're constantly going to be getting updates, you're probably going to need some sort of WebSockets connection. Versus if you're doing a pull model, maybe you're having some sort of HTTP long polling. And obviously, WebSockets is real time. You can get information immediately, and if you're long polling, then you're going to be sending it periodically. Now obviously, long polling tends to be a little bit more resource intensive. Also, if the cadence of your polls, if it's not correct, most of the time you're actually going to return nothing. So it depends on kind of what your use case is, right? If there's a lot of information that's coming in, so for example, if you follow a ton of people and they're celebrities, or they're constantly making lots of posts and there's lots of things that need to be updated, then perhaps one approach is better than the other. So for example, if you don't really use the app that often, there's no need to maintain kind of a WebSocket connection. You're probably fine with log polling. Or actually, hold on. Let me come back to that one, because I think I got them mixed up. Anyway, okay, let's just go back a second. And okay. So let's see. Yeah, so we have the push model versus the pull model, WebSockets versus long polling. Okay, I've completely lost my train of thought. I will come back to this one at some point. So yeah, let's just come back to that one, because I completely just messed myself up there. And in the interest of not ruining everything that I've recorded so far, we'll just come back to it. Okay, what are some other considerations we want to make here? So obviously, when we're fetching the feed, what we want to do here is, your feed is going to be very long, right? And there's only actually so much screen real estate that you have on your phone at one time. We have wide phones, but we don't have really long phones that, are miles long. So you actually don't need to fetch everything at a time, which kind of plays into that we probably want some sort of pagination that's built into our fetch feed, right? Because maybe you just fetch the first 10 items, because that's, what can be safely rendered and in a good amount of time to fetch from the server. If we're fetching too many things, then it can get expensive, especially if we have to go into kind of cold storage. And let's see. So we want some sort of pagination, right? And this makes sense because there's only so much we can render on the screen at one time anyway. There's no point of fetching more. The user might not actually view it. Maybe they just want to see the top 10 posts from their friends, and after that they're just going to close the app. So we'll just kind of have a model where if you want more data, we'll load it for you quickly, and pagination is going to help us here. Obviously, this is going to introduce a little bit of a cost on the server side because you need to have our APIs work with this pagination, but there's a lot of technologies which can handle this for you. For example, GraphQL, if you're using Relay, can handle this kind of outside of the box, but let's not get too much into kind of the technologies here. Let's just know that we're going to need some sort of pagination here to make sure that we're not overfetching data and slowing down our requests and making it a good experience for our user. Okay. We already talked about different devices. Now, I guess there also is the topic of high volume posts. And if we think about this, obviously some people are going to be celebrities, right? What is it, like Dwayne "The Rock" Johnson is the most followed person, or I don't know who it is these days. I don't actually use Instagram too much. But people are going to have lots of followers. They're going to have, lots of interactions on their posts. And do we need to actually show this in real time? And the answer is probably not. So for things like likes on a given post, it doesn't actually matter whether it's that accurate. If you have 1 million likes on your photo, what's the difference if we show that you have 1 million likes versus 1,050,431 likes? Who cares? Like, it's still a lot of likes. We don't actually need the real-time kind of number here. We just want an estimate. And this actually plays into kind of why we opted to have this kind of async tier, because we can process things like likes, follows later on, right? It's fine if we don't have the most up-to-date like counts for a given user, or even sometimes it's fine if you don't see your friend's post a little bit after until we kind of finish processing all of that metadata. So that's kind of why we have the async tier. If we were in a system which actually had comments, then this brings into kind of consideration, okay, well, what happens if we want live comments? This obviously makes it a bit harder. Then maybe you have to switch on for given users. If they have above a certain amount of followers, then you have to switch on certain features in your application, such that, we're able to fetch things real time. But for the most part, we can just say, when dealing with high volume posts, we're okay with not showing kind of the most up-to-date information at all times, right? If you're just fetching some subset of the comments and maybe the rest are still processing, that's fine. If you're not getting the most up-to-date like count, that's fine. We don't have to kind of worry about that too much. Okay, so what else can we kind of talk about? So we also talked about caching on the user side. And I guess one other thing that we can talk about is kind of optimistic rendering, which, let's see, optimistic rendering. So what is this? Optimistic rendering is essentially when you perform some action on the front end, you send a request to the server to handle it, but you can actually mock the front end to pretend as if that operation actually occurred, when in reality it may not actually have been reflected in the database. And this actually plays into kind of our async tier again, because for example, let's say the client, they send a request to the server to like someone's post. So the web server tier will actually run that off to the async queue. It's going to be a job that, okay, this user liked this user's post, this is the post ID, and the async tier will eventually update the metadata database with that information. But this may take some time, especially if there's a queue of other jobs that needs to be processed, and the actual time when that like gets processed may be minutes down the line, which we don't need to actually tell the user about that. We can actually just, as soon as you double tap on a photo or click the heart or click like if it's Facebook, you can actually just render it as if it happened immediately, as long as the server kind of gets the the command that, okay, we need to like this post from this user, this post ID, and we actually add it to our job queue. Once we have the confirmation that it's in the queue, that's really all we need. And eventually it will be processed, and we can actually just render on the screen as if it's been uploaded. If it's already been liked, right? We can fill in the heart, we can increment the like counter on the thing, or you can post your comment in the world that we have comments and have it show up on the thing, and we'll kind of just mock it as if it's live. And we can also do this if you posting something, we can have it just be appended to your kind of your local cache, and show up as a post there, but in reality, actually other people aren't seeing it, but you see it as if it's like in your feed, like, oh, you made this post, but actually other people can't see it yet because we haven't finished processing it. You can think about it as we've sent all the metadata to the server. The server has confirmed that it's received it. It's going to eventually put it into the database. And at that point, we know, okay, we have our durable write. Maybe it's not done yet, but we've sent all of the required information to the service that's going to handle that. We can now just show it in our newsfeed to actually make it look like we've done it. And that way the experience is snappy, right? If you think about it, if you uploaded a photo and then it like disappeared for, I don't know, maybe it takes actually 5 minutes to process it and you're like, where's my thing? Am I going to have to repost again? And then you repost it again, then that's a terrible experience. Whereas if you do this, then it can show up immediately. You're like, okay, it's been accepted. And then, you probably won't even notice that you actually don't start getting likes or comments or interactions on your content for maybe 5 minutes, because actually that's what it took to actually start showing it to other people, right? You not only have to update the databases, you have to write to the blob storage, maybe you have to store it in the CDN, and then you also have to tell the newsfeed service to actually update other people's newsfeeds, and then they refresh their newsfeed, and then they see your posts, and then they can start interacting with it. All this takes time, and you don't want to wait for all of that to complete for you to actually for you to make it seem like your post has gone live. So we can actually make use of optimistic rendering and to actually just show in your app that you actually made the post. It's there. Again, you might not actually be able to interact with it, other people, but to you as the user, it at least looks like it's gone through, and it kind of just gives you a better experience there. Okay, let's see. Is there anything else I wanted to talk about? I think that's generally it. Let's see. I might review my notes for a second and get back to you. Otherwise, I think that's it. Ah, right. I forgot. I promised I would come back to kind of the WebSockets versus long polling. And essentially, I think the way that I think about it is, if we have a user that follows a ton of people, those people post all the time, and they're constantly generating content, then most likely for that person, we want the app to kind of update on its own and get those updates in real time, because there's going to be a lot of them coming in. There's a lot of interactions happening. People are liking their photos, leaving comments, they're getting notifications. And for these kind of high volume / power users, most likely it's important to actually get this data kind of in real time. So for them, it makes more sense to actually have it as a WebSocket connection, so we can get this stuff instantly. And then they can, interact with the app. So for power users, WebSockets to get real-time updates, likes, actually we're not doing comments, but you get the data. So comments, new posts. So for them, it makes sense to actually have this. Whereas, if you're the average Joe Schmo, you have 100 followers, they're never posting, it probably makes sense to have HTTP long polling with a very kind of long kind of poll duration. Or if you're even going to poll at all, maybe you can just have it be a poll model for them, because it really doesn't make sense to do it. If you're constantly going to be returning nothing when you poll, then you're just wasting network packets, and there's no point, right? You're making redundant calls to your service, you're clogging down your machines, so it probably doesn't make sense. So maybe we can have some delineation based on like a power user and a normal user, at which point, we'll switch to kind of using a pull-based model versus a push-based model. So the push-based makes sense for people who are actually getting interactions, and for people who barely use the app or they don't have many friends or followers, then we probably don't need to be constantly feeding them the latest thing. It doesn't matter. They can just pull that content to get it, and they can have it. So for, I guess, high level pull, this is for non-power users, and then the push model is for kind of these power users. Okay, so that I think is it. Looking at the time, it looks like I've been talking for about 45 minutes, which is generally what you're going to have in these interviews. And I guess just to recap, I mean, the first thing we did was go over the requirements. Obviously, there's no interviewer here. I can't get the full requirements, but we just made the assumption that you need to post photos and videos. You're going to have a news feed. This is the scale of our system here. It's quite large. These are the kind of models we needed. Then we talked about the high level kind of design of the system and what elements we need and kind of what considerations we made to actually give the user a good experience. For example, splitting our web server tier between reads and writes, because most likely writes are going to take longer, so we don't want someone to be blocked when they're just trying to read data. We're going to have an async queue to process operations, for example, processing likes, follows, compressing images. And, when this async tier, actually we can add to this and we can say, I don't know, new posts. So obviously when a new post happened, then this is going to update, or this is going to talk to the newsfeed generation service, and this would update the cache for that user. And that way, when the user next requests their feed, they'll have the most recent news feed for them. And if we don't have it in the cache, then we'll fall back to the service, which will probably talk to the database to actually query it manually. Ideally, we don't do that because it's a expensive operation, but for people who don't use the app often, then there's no reason to store them in the cache. We talked about how we'll need a metadata database to store our models here. We're going to need a blob storage for photos and videos, a CDN to cache, these static resources close to the user so they have a quick loading time and a better experience. We did a bit of a deep dive into why we actually don't want to be storing full resolution photos and videos to save network bandwidth, save storage bandwidth. Also, we talked about how we probably want to scale down our photos and videos and actually store different variations of that original photo, such that we can actually serve this to users based on the device class that they're getting it. The newest iPhone is going to require a different kind of photo and video from an Android that was 8 years old. Maybe it can't handle that kind of data, or maybe the person doesn't have that much data on their plan. Things like this, these are real world kind of examples. Then we talked about some of the APIs. To be honest, I did not do the best job on the APIs. I think, one thing that we could have talked about more is kind of the response model. What is it, like a get request, a post request? I mean, for most of these, it's pretty obvious. Like these are all going to be, I guess, post requests. This one's going to be a get request, but you get the idea. If you wanted to deep dive more into the models, I kind of wanted to speak about kind of the broader system as a whole instead of talking about the API response codes. It's not really that interesting. And I think for the E5 level, you're probably going to want to think on a higher level as opposed to getting into like API response codes. It's not really that important. Then we also talked about how to improve the user experience, maybe you want to cache the feed on the client side, and we only want to fetch posts since the last time that we fetched, such that we're not overfetching data, and then the user can actually, when they open the app, they can actually render something based on the information they have cached, instead of the entire app being a loading kind of flickering screen. We also talked about optimistic rendering, which is what happens when, for example, you do a like, and, maybe the server doesn't process it for 30 seconds, but you can actually update the UI to make it seem like it happened immediately. And that just kind of gives the user a feeling like your app is super fast, it's super snappy. As soon as I click something, it shows up, when in reality, it just looks like that for you, but the server still hasn't processed it. And again, this ties into kind of why we have an async queue and an async tier to kind of tier. My microphone cut off for some reason, but anyway, we have the async tier to process things like that. We also talked about the need for pagination when fetching the feed. Obviously, there's only so much information that we can show on a screen at one time. Even, the biggest desktop screens, you're not going to be able to show that much content. So there's no reason to fetch. If the feed is going to be 100 items long, there's no reason to fetch all 100 items. You can maybe do 10 at a time. And as soon as the user actually starts getting close to the end of their feed, we can send a request to fetch the feed for the next page. We also talked about high volume posts and how you don't need to have the most up-to-date comments. You don't have to have all the most up-to-date likes. You can have the best kind of approximation of what up-to-date is, but you can let the server catch up later. And we do this for, high volume ones because it's just too much to keep up with in real time. In some cases, maybe if it's like a stream or something, then you do want real-time comments and likes and interactions, but that's kind of story for another day. We won't get into it. And then in terms of actually interacting with the server, we talked about a push model versus a pull model, how if you're someone where you have a lot of followers, there's a lot of interactions going on, you're constantly commenting, liking things, and people are doing the same for you, then you probably want that feedback in real time. So most likely for you, maybe it makes sense to have a WebSocket connection or maybe an HTTP long polling where you actually, the poll duration is not very long, so you're constantly getting requests. So that way it feels like a real-time experience. But for non-power users who don't have a lot of friends, who don't have a lot of followers, there's not much to actually show them. Having all of this connection overhead and sending all those requests is just wasted network packets, and it's quite resource intensive. So we don't actually want to do that. Anyway, I think I've been talking for probably 50 minutes now. I'm starting to lose my voice. Throat is definitely dry, but I think got through and talked about kind of what I wanted to talk about, and I think I'm happy with that. Obviously, on the day, your interviewer will drive you down the path that they want to talk about. In this, it's more of a monologue. I'm just talking to myself, and there's no one there to stop me, to ask me questions, to probe my knowledge. So I'm really just trying to give a holistic overview and talking about some areas where you might want to talk more if you have the expertise and things like that. But anyway, I hope this video was helpful. There's not a lot of content on this out there. Obviously, designing Instagram is a popular system design question, but no one really focuses on the kind of user aspect of it, which it's not too far from the system design one. A lot of these topics are very similar, but you really need to make sure that you're just tying it back to the user experience and using that to kind of justify some of your decisions. And you can worry less about things like actually scaling the system, how you're going to shard your data and things like that. Anyway, if you found the video useful, why not leave it a like and a comment for the algorithm. Subscribe to the channel if you haven't already, and I will see you in the next one. Bye.